In this video, I'm going to go through some examples. So let's get started. Question 1. Let f be a function such that f of x equals x squared minus x minus 12, and its domain is -4 and 8. What is the meaning of that? You know, this function is a polynomial function, and its domain is all real values. We can find any value of x, but in this case, this domain is a restricted domain. Restricted from -4 to 8. We can find all values from -4 to 8. And some students get confused and say, we can find any value of x. For instance, we can find the value of 10, because 10 squared minus 10 minus 12, we will get a value for the function. But in this case, this domain is restricted domain from -4 to 8, as it given, or as x is defined. And we have g of x, and g of x is given as x minus 4, and this function is a linear function, and its domain -7 and 4. So as I said, it's a restricted domain. And I want to find f plus g x. The meaning of that, to add f of x and g of x. So let's add them: x squared minus x minus 12 plus x minus 4. So 12b at the end, x squared, okay, minus x and plus x, they are going to be cancelled. And we have minus 16. And this function again is a polynomial function. We can find any value for this function. But as I said, we have two restricted domains. For the first one, for the first function, and for the second function. We can find all values from -4 closed, a solid circle, -4 to 8 closed. This for the first function. And for the second function, the domain is -7, and for -7, it's -7, closed, shade the circle, and to 4 closed, 4 closed. That's it. Simply, if we are talking about the first function f of x, we can find all values from -4 to 8. And if we're talking about g of x, we can find all values for x from -7 to 4. But I added g to f. I added the two functions together. What is the domain? In this case, we will find the common domain. We will find all values that work with both of them. So all values that work for both of them from -4 closed to 4 closed. So what is the domain? The domain is going to be -4 closed to 4 closed. This is the domain for the first function, or the first question, f plus g. What about the second question, which is f minus g? So we will follow the same steps, but in this case, we will subtract. We will subtract f, okay, fx. We'll write fx minus gx. So for the second question, it's x squared minus x minus 12 minus x minus 4. X squared minus x minus 12 here, minus x minus 4. So you will end up with x squared minus x and minus x minus 2x, and minus 12 minus 4 is going to be -16. This is the function f minus g. What is the domain? The domain as f plus g, because we have values for f from negative 8 closed. Okay, for the first one, 2, 4 closed. And for the second one, let's go back and check it again. From negative 4 to 8. From negative 4 to 8, I made a mistake. From negative 4 to 8, negative 4 to 8, closed. And the second one, from, let's check it again, from negative 7 to 4. So it's from negative 7 here, negative 7 closed to 4. So what is the common domain for all values of x we can find for the two functions? We can find all values of x for the two functions starting from negative 4 to reaching 4. So the domain from negative 4 to 4, because it's a restricted domain for both of them. The third question, I want to find f times g. So in this case, we are going to multiply the first function, f x minus x squared minus x minus 12. X squared minus x minus 12 multiplied by x minus 4. So you can do it and multiply, expand, then collect like terms. And in this case, we'll find the domain. You know, it will be the same as I said in adding and as I said in subtracting. The domain of the first function from negative 8 as x is defined from negative 4 to 8, negative 4 to 8, negative 4 closed to 8 closed, and from negative 7 closed to 4 closed. And I want to find all values of x that work with them, with the two functions. So the common domain, it's from negative 4 to 4. All these values work with the two functions. That for x times f times g. In the question 4, we have f divided by g. And what is the meaning of that? We will divide x minus 4, this one. We'll divide x minus 4 by x squared minus x minus 12. X squared minus x minus 12 over x minus 4. And what is the domain? The domain for both of them, will find the intersection part on the number line. But we have something we couldn't find. You know, the domain from our previous studies, we couldn't find the value of 4. Do you know why? Because 4 makes the denominator 0. So the domain is our difference, the zeros of the denominator. And we have in the denominator x minus 4. So let x minus 4 equal 0, so x equals 4. So this value makes the denominator 0. So as I explained, what is the common domain? We will follow the same steps. We'll draw the number line, and from negative 8 to 4, and from negative 7 to 4. So it's negative 4 to 4. Closed. Difference except 4. You know why except 4? Because we couldn't find the value of 4 in the denominator. When put in instead of x4, we will get 0. So in this case, what is the domain? The domain is going to be -4 closed and 4 opened. And why is that? Why 4 is opened, not closed? Because 4 makes the denominator 0. And we should simplify if we have something to simplify. This one is factorized as x minus 4 and x plus 3 divided by x minus 4. Cancel them out. You end up with x plus 3. And x plus 3, what is the domain of this function? Is -4 closed and 4 open. That's it. Determine the domain of each of the real functions defined by the following rules. Actually, we have two functions here. And the first function, let's call it f1, and this function is f2. And I have a square root, and under the square root, we have x minus 1. You know, x minus 1 for this function must be greater than or equal to 0. Okay, because we can find all values under the square root. If the values under the square roots, under any square root is 0 or positive. So x minus 1 greater than or equal to 0. So move minus 1 to the next side, x greater than or equal to 1. This for the domain of the first function. And what about the domain of the second function? That's a square root, and we have x plus 2 written inside. So x plus 2 must be greater than or equal to 0. Move to the next side, then x greater than or equal to -2. On the number line, just determine or shade all values we can find for x. It's from 1 till positive infinity, greater than or equal. And for the second one, from -2 closed to positive infinity. What is the common part, okay, of the two functions? We can find all values starting from 1. So we'll find the intersection between them starting from 1 till reaching positive infinity. So what is the domain? Domain, it's 1 closed to positive infinity. Let's go to the next one. I have here a square root of x minus 4 divided by x minus 6. Let's analyze it. So for the numerator, x minus 4 must be greater than or equal to 0. So x must be greater than or equal to 4. What about the denominator? The denominator is a linear function, and we can find any value for the linear function. But because x minus 6 is written in the denominator, x minus 6. So x minus 6 being written in the denominator, we couldn't find the value of 6 because 6 makes the denominator 0. So for x minus 6, for this function, so we deal with them as two functions. We deal with them as two functions. For the first function, all values of x must be greater than or equal to 4. And for x minus 6, we can find any value for x. So we can find any real values for x except 6. So on the number line, we have for the first function, we can find all values starting from 4 till reaching positive infinity. This is the domain for the first function. And the domain for the second function, all values except 6. And 6 is after 4, so we have 6. We couldn't find the value of 6. So what is the common domain? The common domain, it will be our, 4 closed to positive infinity, difference 6, except 6. Okay, this is the domain for the both of them. I have square root of x minus 3 over 5 minus x. You know, x minus 3 must be greater than or equal to 0 because x minus 3 is written up in the denominator. And 5 minus x must be greater than 0 only, not equal to 0. You know why? Because 5 minus x is written down in the denominator. So we couldn't put 0 down in the denominator. So for the first one, move 3 to the next side. So x greater than or equal to 3. And for the second one, it's negative x greater than negative 5, then divide by negative 1, and change the direction of the inequality. So x less than 5. So we have two restrictions for the two functions. We have two conditions for each one of them. For the first function, x must be greater than or equal to 3. So we will go in this direction. Okay. And for the second one, x is less than 5. So 5, but less than 5, not equal to 5. And less than, we will take this direction, less than. So again, for the first function, we can find all values greater than or equal to 3. And for the second function, we can find all values which are less than 5. What is the common part? What is the shaded part between them? We can find now for the two functions starting from 3 till 5 opened, not closed. So what is the domain? The domain is 3 closed and 5 opened. Let's end our lesson by this example. And you should read it well and focus on the square root. You know, I have a square root written, and under the square root we have numerator and denominator. So let's analyze it. What are all possible values for x minus 3 over x minus 5? You know, if we have a square root of positive value divided by positive value, so we can find the value of the square root of positive divided by positive. And what if we have negative up and positive down? You know, we couldn't find the value of that because negative divided by positive is negative, okay? And we couldn't find the value of any negative, none. What if we have positive over negative? Yes, it's positive over negative. When dividing them, it's negative. So we couldn't find the value of the square root if the numerator is positive and the denominator is negative. And what if we have a square root of negative value over negative value? You know, when dividing negative by negative, we will get positive. So in this example, we are going to just check the sign. Check the sign of the numerator and the sign of the denominator. So how can we check the sign of x minus 3? So let's write x minus 3 equals 0. So x equals 3. 3 makes x minus 3 as 0. 3 makes the denominator 0. So for 3, if x is 3, let's take it step by step. If x is 3, then the value is 0. X 3, the value is 0. When x is greater than 3, let's take a number greater than 3 and put it in this function, x minus 3, like 100. 100 minus 3 is 97. So all values more than 3 is positive, and all values less than 3 is negative. Okay, this for the first function. What about x minus 5? Let's check the sign of x minus 5. So write x minus 5 equals 0. So x equals 5. You know, 5, when x equals 5, the value is 0. When x greater than 5, when x is greater than 5, so f of x is positive. When x is less than 5, the function is negative. Okay, let's draw them together on one number line. So we will start with 3, 3 makes the function equals to 0, 3 equals 0, f of x, okay? And what is after 3 is positive. All values are positive values. And less than 3, negative. What about 5? 5, we write 5 in this place, 5 here. And 5 makes the function 0. And what is greater than 5 is positive. And all values of x less than 5, all values of x are going to be negative. So once again, for the first function, 3, 0, okay? So we have a function up and down, just divide them. So for this part, when we have negative for the first one and negative for the second one, you know, negative divided by negative is positive. So this part from the number line work with us because negative divided by negative is positive. Okay? And this part from the number line work with us because positive divided by positive is positive. What about 3? You know, 3 equals 0, and we don't have any problem in 0 of the numerators. So any numerator equals 0, okay, that works with us. So 3 work with us. And after 3 to reach in 5, this part doesn't work with us, you know? This part doesn't work with us because positive divided by negative is negative. So what is the domain in this case? The domain we can write from 3 closed to negative infinity to 3 closed, union 5 open. And why 5 open? Because 5 makes the denominator 0. So 5 open till reaching positive infinity. This is the domain for this function. See you in the coming episodes. Goodbye.